Welcome back to the channel. In the previous videos, we walked through how to use GitHub's Spec-Kit methodology to build a simple web-based virtual assistant that helps a human solve the New York Times connection puzzle. If you haven't seen those earlier videos, I highly recommend checking them out. Links are in the description below. The business problem remains the same. We want to help a human quickly and accurately solve the New York Times connections puzzle by building a tool that allows the user to interact with potential word groupings, refine their guesses, and leverage the reasoning ability of large language models. So far, we've used GitHub's Spec-Kit, an open source framework for specification-driven development, to guide every step in the process. Let's do a quick review of earlier phases. In phase 1, it was all about laying the foundation. We established the project structure, built the initial WebUI, implemented a React front end using TypeScript, created a Python backend with stub code to support the front end during early testing, and put the testing framework in place. In phase 2, took things further by integrating large language models for generating puzzle solutions. We enhanced the backend to support multiple LLM providers, both OpenAI and Ollama, and expanded the UI to accommodate these options. These phases set the stage for what we're about to explore next. In phase 3, our goal is straightforward but impactful. We want to refactor the WebUI for a more polished experience and create the foundation for the next set of enhancements. And importantly, we want to demonstrate Spec-Kit isn't only for new greenfield projects. It works equally well for brownfield development, where an existing application is being modified or extended. This phase lays the groundwork for cleaner, more intuitive UI that we can expand on in future videos. This is what we currently have after phase 2. The existing web UI had two primary screens, the initial landing page and the gameplay screen that users interact while solving the puzzle. It was functional but wasn't optimized for clarity or navigation. That's where phase 3 comes in. Here's the mock-up of the new phase 3 UI. We still have the familiar initial page and the play screen, but we've added a major improvement, a left side navigation bar. This new layout sets up for future enhancements such as multi-puzzle support, history tracking, and more complex interactions. Everything in this phase, just like the previous ones, was driven by Spec-Kit. Here is a summary of the phase 3 durations. All activities in phase 3 were performed using VSCode agent mode with GitHub Copilot assisting throughout the workflow. Since the project's constitution was established as part of phase 1, we simply reused it here because the core purpose and structure of the project remained the same. For specification and planning stages, Claude Sonnet 4.5 was used instead of Claude Sonnet 4 due to its key improvements for coding, reasoning, and long-running task handling. Sonnet 4.5 does seem to take longer, but the increased capability appears to justify the additional time. Duration for these stages, including the implementation, was about 77 minutes. For the actual implementation step, Claude Sonnet 4 was chosen for its faster response time, helping speed up the actual code generation and testing phase. Its duration is included within the overall total cited above. One issue surfaced after implementation completed. For this, GitHub Copilot in agent mode with Claude Sonnet 4 was used to perform a root cause analysis and correct the error. This took about 12 minutes. In total, for phase 3, it took 89 minutes to implement the phase 3 changes. So what's the result? A fully working refactored UI with updated unit tests and integration tests built in just 1.5 hours. This demonstrates not just the efficiency of using AI tools, but the power of coupling them with strong engineering discipline like specification-driven development. And remember, this is only the beginning of a new UI direction. Future phases will build on the structure and introduce even more features. I'll show you exactly how VSCode agent mode and GitHub Copilot drove the specification-driven development workflow for phase 3. You'll see how Copilot, working in agent mode, created the specs, tightened up the details, and then generated the actual code needed for the UI refactor. And of course, a human developer was essential in keeping everything on track. I'll also walk you through the newly refactored UI and show a real example of how agent mode helped track down and fix a post-implementation issue. By the end, you'll get a clear end-to-end view of how specification-driven development and AI assistant development came together to deliver Phase 3 efficiently. Okay, this is now where I'm going to provide the high-level specification. And for this, I'm using some pre-written high-level specification that you're now seeing here. I'm just going to copy and paste it into the Copilot chat area. And this high-level specification provides the main change is adding that left sidebar where I can now set up a new puzzle, and I'm making sure that the rest of the connection puzzle is not affected when I make the change. Okay, we'll now fast forward through the process where GitHub Copilot generates the specification for this change. I'll be back in about 15 seconds to continue the narration. Okay, GitHub Copilot has finished generating the specifications. So let's now keep what it generated and let's review it. Alright, we're looking at the requirements document to see if from its checklist if the specification is meeting its quality standards. And it appears that from a quality perspective that the specification is sound and meeting all of its all the requirements. Alright, so now let's look at the actual specification itself. And you can see here it's divided the high-level specification into several user stories that will now look at each of the user stories to see if they meet the intent of the change. Alright, this first user story looks like it's just set at the web page. The second user story looks like it's describing the actions with the left sidebar. And this third story looks like it's describing what needs to happen while the game is being played. And this upcoming fourth user story describes what occurs at the end of the game. Alright, and now we're coming to some edge cases and a list of the functional requirements. And we can see like that it looks like these look like reasonable functional requirements capturing the intent of the change. And if these changes aren't suitable, we have the ability to manually change them here if needed. And now we're getting to some key entities. It's discussing describing the layout changes about persistent title bar, sidebar, in the main area, and this is now describing the success criteria, the measurable outcomes that can be validated. And we're now documenting the assumptions that we're making. Basically, we're using a lot of the existing structures, and finally ending up with things that are out of scope. Okay, now I'll use speckit.clarify command, where it will review the specification and identify if there were any gaps that I had missed. It will ask a series of questions, which I'll provide responses to, and based on those responses, Spec-Kit and GitHub Copilot will augment the specification. We'll fast forward through this section, and I'll be back in about 20 seconds to continue the narration. Okay, looks like the clarification process is completed. GitHub Copilot and Spec-Kit is now providing a summary of the questions and the responses. And everything looks like it's reasonable. And now saying the next thing we can do is do the technical plan. But before we do that, let's keep the changes. And now what I want to do is commit the updates, the specification and the clarified specifications into Git. Let's do a commit for that, just so that we checkpoint the progress of our work. So if anything goes wrong, we can always come back to this point. Okay, we'll now build the technical plan for this change. For that, we'll use the speckit.plan command, and I'll come back in about 30 seconds to continue the narration. All right, with the technical plan now defined, we now need to define the detailed task to be accomplished in building the features. So for this, we'll use speckit's task command. We'll fast forward through this portion, and I'll be back in about 30 seconds to continue the narration. With the task now defined, we'll use the analyze command to confirm that the generated tasks cover both the functional and technical requirements. Okay, as we can see, the analysis is complete. We're now seeing a summary of that analysis, and we're basically says that we're able to proceed with implementation, that the tasks cover all the requirements. All right, now that the tasks have been defined and confirmed, we'll now commit this. We'll do a git commit to commit these changes to the repository. Okay, we'll now start the implementation. We'll use SpeckKit's implement command to implement the tasks that were just defined. We'll fast forward through this section, and I'll be back in about 45 seconds to continue the narration. Well, it looks like the first part of the implementation has completed, where it looks like it has updated the WebUI to include the sidebar with the options to start a new game from a file. So let's see. All right, so that looks good. All right, with that in place, well, actually, let's try and give this a shot. Let's see what how the new front end looks like. Okay, we start a browser. Let's navigate to the front end. All right, we see the sidebar. See what we're asking. All right, so we'll click on starting a new game from a file. All right, this looks good. All right, we'll choose a file. We'll choose a puzzle file. All right, and then oh, okay. We don't have the backend running, so that's why we got the network error. So let's bring up a backend and see what happens. It should work with the existing backend. All right, the backend is up, and now we're gonna set up the puzzle, and it works. All right, this is encouraging. The initial changes look good, and so now let's continue on with the work. All right, so let's now continue on with the implementation. I'll be back in about 15 seconds to continue the narration. It looks like the implementation is done, but it looks like I still have some failing tests. So first I'm going to ask the agent to run all the front-end tests to see what's failing. And it looks like it's identified the failing tests, and it looks like it's related to some legacy tests that haven't been updated for the new interface. I'm now going to ask the agent to fix the failing tests. We'll fast forward through this part where the agent is fixing the tests. I'll be back in about 15 seconds to continue the narration. All right, the agent has completed fixing the tasks. It looks like all tests are now passing. So this is encouraging. With that, let's now commit the changes that we've just made to the Git repo. All right, now that we've fixed the tests, let's now actually start the connection solver assistant and see what happens. All right, first we'll bring up the back end. Now we'll bring up the front end with the new web UI. And now let's start the browser. Alright, so let's now set up a new puzzle. Alright, this is good. Alright, so now let's select the large language model. We use GPT-5 Mini for this, and we'll get our first recommendation. Right now the UI is behaving as it was in the last phase, so this is good. Alright, this looks like it's a correct answer. And then, alright, we have the previous guess updated the counters. Alright, let's get our next group of 4. Alright, we've gotten a next set, and this looks like now this is the correct blue group. So we'll, and we've updated the previous guesses. The counters are updated correctly. Let's get our third word group. All right. Okay. And then this looks like the purple group. All right. Updated the counters. Previous guesses are looking good. All right. Let's get the last recommendation for the last group. All right. And this is the last correct yellow group. All right. Now we have our message that says we've solved the puzzle. We've got our previous guesses. The counters all reflect correctly. So now let's start a new puzzle. Oh, okay, we start a new puzzle, but it looks like we have an issue. The previous guesses uh, haven't been reset. So we have the guesses from the last puzzle. Looks like this is an issue we'll need to fix. All right. Okay. Well, let's shut everything down, and we'll have the agent work on fixing the issue we just noted. Now I'm going to ask the agent to help me fix the issue noted about the previous guesses not being cleared out. So here I'm going to describe the issue to the agent. So if I request a new game after the prior game ends, the previous guest list is not cleared for the new game. What is the root cause for this? Make recommendations for a fix. I want to review and approve recommendations before any code changes. Okay, the agent has now come back with a root cause analysis and with some options to fix. Alright, it's explaining the root cause. It's basically saying how the initialization occurs and that something is missed when initializing the new game. Okay, it's showing the error, the problematic code, and it's now coming up with a couple of options on how to fix it. Alright, so it's presenting two options on how this issue can be fixed, and it's making a recommendation. So now let me look at these options, see if I can understand what it's trying to do and the differences. Alright, it's recommending option 1, but I think for my purposes I like the option 2 better, where it completely resets the entire state. That seems cleaner to me. Alright, so with that I'm going to say option 2. Okay, the GitHub Copilot agent has now put in a fix, so let's test it out. Let's start the backend server, and now we'll start the front-end server. Alright, the servers are now up and running. Let's now start a browser. Okay, and we'll now set up a puzzle, our first puzzle. And then we'll just solve this puzzle and see what happens when we start the next one. We're now entering the last response for the puzzle, and we've solved it, so that looks good. And now let's try start a new game, a new puzzle. Okay, we're going to select a file, set up the puzzle, and oh, good. Now the previous responses list is empty, which is good. The problem has been fixed, so now let's just shut everything down. With phase 3 now complete, these are the next set of enhancements planned. In phase 4, we'll be adding support for initializing a puzzle from a screenshot, and in phase 5, we'll add support for storing puzzle results in a local database. All of these enhancements will be done using Spec-Kit and Specification-Driven Development. Stay tuned and look forward for these future videos. If you like the content, please like and subscribe. Thank you.